Hello everyone, I'm going to show you an example of how to do a chi-square test of independence. And so hopefully this will clear some things up for you. Here's our example. In these times of educational reform, attention has been focused on preschool for all children. Since many districts are facing budget cuts, funding preschool programs may impact other offerings. Before making the recommendation, administrators in a large urban district take a random sample of 50 7th graders and compare the pre-algebra achievement levels of those who attended preschool and those who did not. If achievement is independent of attending preschool, then the proportions at each level should be equal. Use the counts in the frequency table to determine if there is an association between attending preschool and pre-algebra achievement level. So the first thing I'm going to do is I'm going to put our data into our matrix. So I'll go over to second matrix, go over to edit number 1, and I'm going to enter in, this is a 2 by 3 matrix, so I'm going to enter in the numbers 8, 6, 6, 6, 15, enter 9. Alright, so there's our matrix, so I can quit. Alright, so this is our parameter, so our null hypothesis is going to be that achievement is independent of attending preschool and our alternate is that achievement is dependent on attending preschool. Okay, in order to perform this test, we have to test our assumptions. So our first assumption is we are given an SRS of students and all expected counts are greater than or equal to 5. Now I haven't actually checked that yet. I haven't checked the expected counts, so we're going to go ahead and do that. So in our stat menu, if we go to stat, go over to tests, find the chi-square test, which is letter C, and do this. We put our observed into matrix A, so we have to do that part. The calculator, the chi-square test, will actually calculate the expected values for you and store them in matrix B, and you can look at it in a minute. So the observe, we've input them ourselves. The calculator will figure out what the expected ones are for you, and then we go ahead and calculate it. So let's go ahead and make a note down here. So these are our assumptions. We are performing a chi-square test for independence. Our chi-square value is 2.86, and our p-value is 0.24, and our degrees of freedom is equal to 2. All of these are from the calculator. Now let's go ahead and take a look at those expected counts just to make sure. So if I do second matrix, matrix B is where it stored everything for me. And there they are. And we can see that sure enough, they are all greater than 5. So now up here, I want to go ahead and put them in so that I can show that I did in fact look at them. So 5.6, 8.4, 6, 8.4, 12.6, 9. If you're going to make this claim, this assumption, then you need to show me what your expected values actually are. Alright, so we figured out our chi-square, we figured out our p-value, so we can draw a conclusion now. Since p is greater than 5%, we will fail to reject the null. There is insufficient evidence to claim that achievement is dependent on attending preschool. All right, and that's it. The calculator does most of the work for you. The main thing I'm looking at and I'm concerned about is, did you set up your hypothesis statements correctly? Did you check your assumptions? Did you verify your expected counts? Did you figure out the correct values from the calculator? And was your interpretation of the data and the statistics correct? So hopefully that helped clear some things up, and I will catch you next time.